Here we have question 2 from the Physical Sciences Paper 1, DBE November 2023 exam. Question 2, as usual, is about Newton's laws of motion. In this video, we will be going through it and work through all of these problems. So let us get straight into it. So here we have block A with a mass of 4 kilograms and block B with a mass of 9 kilograms. And these blocks are connected by a light inextensible string, and the blocks are held at rest on a plane which is inclined at an angle of 35 degrees with the horizontal. A constant force F acting parallel to the plane is applied to block B as shown in the diagram below. The blocks now accelerate up the plane at 2 meters per second. The frictional forces acting on blocks A and B are 5,88 newtons and 13,23 newtons, respectively. The first problem we'll be answering says, draw a labeled free body diagram showing all the forces acting on block A. So there is block A, and we know that in a free body diagram, we represent the object with a dot. And now, before we even consult the information we are provided with, we do know that every object that is on the surface of the earth experiences the force of gravity, which is always directly downwards towards the center of the earth. And then, due to this light inextensible string that is connecting these two blocks, block A is going to experience a tension force which is going to be up the slope, and it must be exactly parallel with the slope. Since this block is in contact with the surface, it will experience a normal force due to the surface, and remember that the normal force must always be perpendicular to the surface. And then we were also told that these blocks are experiencing frictional forces. So the friction always opposes the direction of motion. So there it is. And since this block is accelerating, let's call this a kinetic frictional force. And there we go. These are all the forces that are acting on block A, and we can also confirm whether or not we have shown all the required forces by looking on the mark allocation. This is worth 4 marks, and we have shown 4 forces, so everything checks out. And now let us move on to the next part of this question, which says calculate the magnitude of the tension in the string. This is obviously a Newton's second law of motion problem, simply because there is acceleration. So we can solve this problem by applying this law. And what we are going to do is we are going to consider block A. And we must also clearly indicate our positive direction. So we can take the direction up the plane or to the right as our positive direction. And like I said, we are going to be applying Newton's second law of motion, which says F net is equal to ma. Now we need to consider all the forces that are acting on block A in order to evaluate this net force. So we must consider specifically the forces that are acting parallel to the plane, because those are the forces that will be responsible for the acceleration. So the first one is the tension force, and this tension force is acting up the plane, so it will be positive. And then the kinetic frictional force, which is acting in the opposite direction, will be negative. And now we mustn't forget that since these blocks are lying on an inclined plane, it means that the gravitational force can be resolved into the perpendicular components. We are going to have Fg perpendicular, and we also have Fg parallel. So there it is. And these two forces are at an angle of 90 degrees to each other. And then this angle here is going to be equivalent to 35 degrees. All right. And now, what is important to note here is that the FG parallel component is also acting parallel to the surface, which is why we call it FG parallel. So this FG parallel can be given by multiplying the gravitational force with the sine of that angle of 35 degrees in this case. And this is simply because, as you can see here, we have a right angled triangle. And in this right angled triangle, FG parallel forms the opposite side to that angle of 35 degrees. And from the trigonometric ratios, we know that the ratio that combines the opposite side and the hypotenuse side is sine, because opposite over hypotenuse is equal to sine. So we multiply FG by sine. So I will just simply write here FG sine 35 degrees straight away, and that's equal to MA. And now the next thing that we must do is to substitute in all the values that we know. The kinetic frictional force as given here is equal to 5,88 newtons for block A. And then we can calculate Fg by taking the mass of block A and multiply it by the gravitational acceleration, which is 9,8. And then we multiply that by sine 35 degrees. And this is equal to the mass of 4 kilograms multiplied by the acceleration of this system of blocks, which we were told that it's equal to 2 meters per second. And we're told that these blocks are accelerating up the plane, meaning that this acceleration is going to be positive. And now the last thing that we need to do is mathematics. We simply need to sum up all of these constant terms, and I'm gonna do that using a calculator. So we have 4 multiplied by 2 on the right hand side, and then I am going to transpose all the constant terms that are on the left hand side to the right hand side. So their signs will change to positive. So I'll add 5,88 and also add 4 multiplied by 9,8 multiplied by sine of 35 degrees. And this gives us 36,36. So this is the magnitude of the tension force. It's 36,36 newtons. Very important not to forget the units. Okay, so now the next question says calculate the magnitude of force F. So force F is obviously that applied force. And again, we are going to be able to do that by applying Newton's second law of motion. But this time around, since that force is specifically acting on block B, we must focus on block B. And we are still taking the same direction as our positive direction. We need to apply Newton's second law of motion once again. But now let's consider the forces that are going to contribute to the net force of block B. First of all, it's this applied force that we are trying to calculate. Other than that, all the rest of the forces are acting in the opposite direction. First, it's the tension force, which is due to the string. And then there's also a frictional force, to be more specific, kinetic friction. And finally, just like block A, this block also has an FG parallel acting on it. But of course, we know that FG parallel can be given by FG sine of 35 degrees, because block B is also lying on the same plane as block A. And all of these are going to be equal to the mass multiplied by the acceleration of this block. We do not know the force, of course. We do know that the tension force is 36,36 newtons from the previous calculation. The frictional force for block B is 13,23. And then we can calculate Fg for block B by taking its mass, which is 9 kilograms, and multiply it by 9.8 meters per second squared. And then we multiply that by sine of 35 degrees. So this will be equal to the mass, which is 9 kilograms, multiplied by the acceleration of these blocks, which is 2 meters per second. And again, that is positive simply because the acceleration is also acting up the plane. Now, what is left for us to do is to use our calculators once again. So let us take out our calculator. So on the right hand side, we have 9 multiplied by 2, and we need to add 36.36 and also add 13.23, and finally add 9 multiplied by 9.8 multiplied by sine of 35 degrees, and this gives us 118.18 newtons. So that is the magnitude of that applied force acting on block B. And now we can move on to the final part of this question. So here we are told that the angle that the plane makes with the horizontal is now decreased. Okay? In other words, the steepness or the slopeness of that plane is now decreased. And the question is, how will this change the kinetic frictional force acting on block A? Choose from increases, decreases, or remains the same. Okay, let us think about this. Initially, this was the plane. Our plane was inclined with an angle of 35 degrees. Now, what we are being told is that the angle of that plane with the horizontal has now been decreased. So let's say that, for an example, it has been decreased maybe to 15 degrees. Okay? So how would that affect the kinetic frictional force acting on block A? In order to understand this, I will draw a free body diagram of block A here. So let's say this is our block A. Of course, we have a normal force acting there, and there is our gravitational force, which acts directly downwards. And of course, as we had already drawn this free body diagram, there's also the frictional force and the tension force, but let us just focus on these two forces. This Fg, as we had also already discussed, has a perpendicular component, Fg perpendicular, as well as the parallel component, Fg parallel. And then this forms an angle of 90 degrees, and then this would be also equal to our angle of 15 degrees. So here you must remember that the kinetic frictional force is given by the normal force multiplied by the coefficient of kinetic friction. And this normal force is actually equal to Fg perpendicular, as shown by this force diagram that we have drawn. And that's simply because the normal force and Fg perpendicular are at equilibrium in this scenario. Additionally, this Fg perpendicular is given by Fg cosine of that angle. So let me just call it theta here. And that is obvious because, as we had already discussed, Fg parallel is given by Fg sine of theta. So if this is given by Fg sine of theta, then the other component will be given by Fg cosine of theta. But if you want to verify it, here is how you can reason again. You can say that Fg perpendicular is an adjacent side relative to this angle of interest. So the adjacent over an hypotenuse is a cosine ratio. So in place of the normal force here, we can substitute in Fg cosine of theta, and then this, all of that needs to be multiplied by mu k. So the coefficient of static friction will remain the same because we are still considering the same plane as before. The only thing that has been changed is the angle. So the coefficient itself is going to remain the same because it's a property of the surface. Now, the normal force itself, as we can see, it changes whenever we are changing the angle that the plane makes with the horizontal. And all that you need to know is whether how does the value of cosine theta change when you are decreasing the size of the angle. And the answer to that is if you decrease the size of the angle, then the value of cosine theta will increase. And of course, now if you are multiplying fg by a bigger number, it means that the size of the normal force is going to increase, which will then cause the magnitude of the kinetic frictional force to increase as well. So the answer here is that this will cause the kinetic frictional force to increase. So that's the answer to this question. And if you are not convinced that the value of cosine theta increases when the angle decreases, I can show you this in a calculator. Initially, the angle of this inclined plane was 35 degrees, right? So let's see whether what is the value of cosine 35. This is equal to 0,819. Now, as per our example here, let's say that we have now decreased this angle to 15 degrees. Let's see what value are we going to get. We are now getting 0,9659, which is clearly bigger than when the angle was 35 degrees. So this clearly shows that if you decrease the angle of theta, or the angle that the plane makes with the horizontal, the normal force is going to increase as a result. And the higher the normal force, the higher the frictional force, because they are directly proportional as shown by this equation. So that's the answer to this question, which brings us to the end of this video. I hope that you have found this to be helpful. Please make sure that you click that like button and subscribe to this channel so that you do not miss on future videos like this one. And please do give me any feedback in the comment section below. See you on the next one. Goodbye.